Great, thanks, Cynthia. Well, what I'm going to do is just try to give you a little bit more of an idea of some of the details of the work we've been doing on the regional, what we call regional assessment, which is either national or subnational in scale, and then and let Keith talk a little bit more about some of the global work. But to give you an idea, the goal I'm after here is to really give you a sense of how the work we've been doing, we think, has advanced the science and our capabilities to understand both climate impact and adaptation, but also how that will then link into this CGRA work that will really, we think, improve the quality of information we can provide to our various stakeholders who, of course, range from people on the ground, farmers, farm advisors, all the way up to people negotiating at the COP. The place I'd like to start is just this observation that in our various discussion with stakeholders, in a sense they've said, okay, climate impact assessment, enough is enough. Yes, the climate's changing. Yes, there are impacts. What do we do about it? So we need to move from assessment to understanding what kind of real actions can be taken. And that operates both in the mitigation dimension and in terms of what I like to call resilient adaptation. And so what I'd like to do now is just give you some examples of how we think with our improved data and modeling are able to really look at specific technologies and understand their potential as ways to both mitigate and sustainably adapt to climate change. So I'm going to talk a little bit about some of the regional assessments that we've been doing with teams in sub-Saharan Africa. We've also been working with teams in South Asia. And unfortunately, I don't have the time to acknowledge all of our collaborators, but I did just want to mention to you this, it's actually 2 volumes of work that were published last year in this Handbook of Climate Change and Agroecosystems. Cynthia and Daniel Hillel were the editors, but in those books you'll find chapters from these various teams around the world, and also, of course, discussion of our methods. Right now, what I'm going to do is just focus for a few minutes on some work done by our collaborators in Zimbabwe, and also a little bit from Senegal over there in the other corner of Africa. As well. And if you're interested in the details of our methods, you can find online at agmip.org this handbook of methods and procedures that we've developed that is really sort of all the details of the methodology. So in this particular example, one key element that we have been working very hard on is how to really develop a more participatory approach to really doing modeling. And one of the most effective ways we've found is to engage stakeholders in the development of the scenarios, the pathways and scenarios. Those of you who work in the climate field may have heard about shared socioeconomic pathways. Well, we're doing something agriculture specific that we call representative agricultural pathways. And this little graphic is just to illustrate what our Zimbabwe team did to implement that idea, which was really an iterative process interacting with their stakeholders to understand the systems, to understand the stakeholder perspectives, and to design these forward-looking scenarios that they could then study. And early in their work several years ago, sorry if this is too small for everybody to read, but basically, could we take the light down? Maybe somebody can. I can't. Thanks for the suggestion. What this graphic on the left is illustrating are some of the outcomes from their work when they did the initial scenarios that were very sort of technologically incremental. And one of the critiques when they went back to their stakeholders in this iterative process was, that's not good enough. If that still leaves 91% of the farm households in poverty, that's just not good enough. We've got to do better than that. And so they had further interaction with stakeholders, further discussions about, to look at what they considered to be a more transformative scenario, and found that could potentially reduce poverty to 43%. So that's just to illustrate the way we're trying to work with stakeholders to really look at specific changes in farming systems and the kinds of consequences they could potentially have. In contrast to what we would contrast this with is much of the more aggregated or in some ways, we econometricians might say reduced form econometric type of analysis that really can't tell us about specific farming systems and how they could either improve or not improve conditions on the ground. And that's the kind of information, again, that our stakeholders want to have. They want to know what can we do and how well will it work. The other graphic I'm just going to share with you the little time I have. How am I doing on time? I'm doing okay. Okay. All right. Great. This graphic. So I just like to dig into this graphic a little bit, and it's got three important messages embedded in it. What it's showing basically is on the horizontal axis, and now it's showing results from that Zimbabwe study area, and the data points you'll find here, the blue and orange ones here in the middle of the graphic are from that Zimbabwe study, and the green and orange ones are from a similar study using the same methods in the peanut basin of Senegal. And on the horizontal axis, we're looking at what I would call is the typical way of looking at climate impacts, which is the average impact in a region like this, versus on the horizontal axis, a measure of vulnerability, namely the proportion of households that could be adversely impacted by climate change. And that's what we feel like is one of the key things we're adding to this type of impact assessment, is to add this dimension. And we hope as we move ahead into the CGRA work to be able to go beyond. Here that measure is done in terms of farm net returns, but we would like to extend to other indicators, more meaningful indicators, for example, of food security and nutrition as well. So we have those two dimensions, and like I said, the blue and orange dots, each one of these dots represents a particular scenario, meaning a combination of climate, a crop model, an economic model, and a socioeconomic scenario, either in the present or future projected conditions where we projected those future conditions in collaboration with the stakeholders. And you can see in the Zimbabwe case that the points are all kind of clustered here in the middle of the picture, showing on average very small impact, yet almost zero average impact corresponds to 50% of the population is actually vulnerable to loss. Now, how the magnitude of those losses is another thing we can look at. I don't have time to show you those numbers here, but I'm sure you can get that point. And so this just illustrates our point that there's a big difference between looking at average impact and percent of the population that's vulnerable. But the second key point about this story is that the Zimbabwe team looked at the data from the IFPRI model, from the impact and some of the other global models, and said, well, in the case of Zimbabwe, for reasons you might surmise, we don't think we're going to be that closely linked to the global markets, so we're actually not going to use the global price predictions for mid-century. We're going to take the current prices and essentially assume they're going to stay kind of like they are now. Versus our team in Senegal felt just the opposite. They felt that, and by the way, so their initial current world condition analysis showed very high vulnerability and quite high average impact, whereas when they projected out into the future with climate change, in part, and I would say very substantially, because of projected future higher prices for the crops that the farmers there are producing and selling, they actually showed positive average impact and much lower, notice not zero vulnerability, but much lower vulnerability. And you can also see the spread in those points. The spread in those points reflects the uncertainty of the climate scenarios and the crop models, but this big jump from the green to the orange shows the effect of using current prices versus future projected prices, and gives you a sort of hint about that economic model uncertainty that Cynthia was talking about, and I think Keith is going to maybe talk about a little bit more when I finish. So to us, this really illustrates how important it is for climate assessments not to, for example, pretend like Africa will be the same in mid-century as it is today. Economic conditions and, of course, farm size, household size, policy, infrastructure investment, all those factors are going to dramatically, I would say, change the story as the more we look out into the future and try to understand the possible vulnerabilities and potential for adaptation to climate. Well, we just wanted to say a quick word about communicating model results to our stakeholders. AgMIP is working very hard on this. This graphic is just to illustrate something we're developing called the AgMIP Impacts Explorer. That's part of this DFID-funded project that I've just been talking about. IFPRI, of course, does things like this and is a great partner for us to learn from as well. And we see that as another really important part of this whole process. Well, let me just finish now by summarize for you, we think there are really three key things that the CGRA activity will produce. And in summary, the first thing is, really for the first time, we hope, truly coordinated global and regional assessments with consistent protocols and scenarios. It's those protocols and scenarios that allow us to make that comparison that I just showed you between Senegal and Zimbabwe and say, it's not the difference in method that's causing those results to be different. It's the difference in the assumptions that we made, for example, about prices that we're using and other things. Now, of course, there are other differences between those regions, agroecologically, but we can really start to sort out the differences impacts. The second key point is that we will hopefully be able to assess mitigation and resilient adaptation of major agricultural systems around the world, accounting for extreme weather events and related economic shocks, for example, the recent food price shocks we've seen over the past 10 years, as well as these long-term sort of trend analyses. And we really think it's important for us to move from this long-run sort of trend equilibrium analysis to really understanding short-term variability and extremes. That's what our stakeholders are asking for, and of course is very important to people who are vulnerable to food shocks, food price shocks, for example. And finally, improve food security and nutrition indicators. We haven't had a lot of time here today to talk more about this point. Perhaps in the discussion we have some time at the end, we could talk a bit more about that. But just in summary, we recognize that currently the best we can do is typically use aggregate calorie availability as a measure of food security. But of course, we need to go beyond that to understand access, utilization, and stability of key nutrients, more than just calories, at the regional and even down to the household level to really get a good understanding of food security and nutrition outcomes. And finally, just a little advertisement. Our next global AgMIP meeting workshop will be June 28th to 30th in Montpellier. And check out our website, agmip.org, to learn more about that. You're all welcome to come and join us à Montpellier, where hopefully the sun will shine. Almost surely. Great. Well, let me end there, and Keith, let me turn it over to you.